Greetings, the Astro 30 here, and welcome to the 1990s. No, seriously. Today I want to have a look at this operational amplifier circuit. I have actually built this before and I know it works. I did say TL072 here. I'm wondering if it will run on an NE5532. I think it will, because in my previous video about how to run an op amp on a single supply using the biasing method of pin 3 of the op amp in this case, it worked out fine. So this is basically a circuit designed to drive an 8 ohm loudspeaker, similar to that, which is an AS3000. You've probably seen this speaker already used in that recreation of that Project 2 from the 160-in-1 electronics project kit, which had mixed results. Didn't put out much in the terms of output. It was actually pretty weak considering. However, I know this circuit to work pretty well, so I'll just explain what's going on here. We've got a non-inverting op amp stage which is biased to the halfway supply voltage point of 9 volt by these two 100k resistors, which is a potential divider or a resistive divider. Our input comes in here on this 3 microfarad 3 or 3.3 microfarad into this non-inverting op amp stage. Its gain is set to a gain of 101 by this 100k resistor and this 1k resistor respectively. The output then comes at pin 1. There's going to be DC here on the output, so it's going to be biasing this next stage correctly to the halfway supply voltage point, and that goes into this class B amplifier stage, which is comprised of a BC337 and a BC327 respectively, and these two transistors have a maximum current capability of 800 mA each, which makes it perfect to drive a loudspeaker. The output of the class B is within the feedback loop of this second op amp stage, and this is operating in a unity gain, or a gain of 1, so there's no actual gain here. It's just acting as a buffer between this stage and the output. That is then fed into this 100 microfarad electrolytic capacitor, which is to remove the DC, and then into the 8 ohm speaker across that in the negative rail. This 10 ohm resistor and this 100 nanofarad capacitor respectively form what is known as a Zobel network, and if you've watched my channel before you know exactly what that's for. It's to help prevent this high gain stage here from going into ultrasonic oscillation when it's driving capacitive loads. It just stops it from going into oscillation, which can be annoying. It may not be ultrasonic, it may even be just normal oscillation, which turns into a howl, a motorboat, all sorts of weird sounds on the output. As I said, this looks like a class B output stage. However, there's going to be DC on the output here too on pin 7. So basically it's biasing these two transistors hard on, so it'd be actually operating in class A more than anything else. That's my understanding of the circuit anyway. So what I'm going to do is I'm going to breadboard this up on my breadboard, and we're going to test it out. I'm going to try the NE5532 first, just to, for shits and giggles. And yeah, what I might do is I might build this input stage first and test to make sure that works. I'm going to probably limit this resistor down to 10k rather than 100k, so I have a gain of 11 rather than 101, because I'm not really needing that much gain. I'd only need this much gain if I was only got like 10 millivolts input here. I want to run something a little bit higher than that, so I'm going to put a 10k there, make the gain stage 11 respectively, and then we'll build the second half and test it as we go. So let's get started. Alrighty, and I've got the first stage built, the non-inverting stage. I did actually end up going with the 100k feedback resistor. I've just put that 50k logarithmic pot in series with the input and my test oscillator. Right, so I'll hook up the battery, and this is an NE5532, so anyone's guess. As unstable as that waveform is, it is actually producing a sinusoidal waveform, so the NE5532 does work quite fine on 9 volt half supply. So drop that right down. I want to see where this maxes out. Ah, there we go. Alright, we're maxing out at 7.45 volt roughly. Drop that down, it's still clipping. Yeah, battery voltage keeps changing, but yeah, I'm going to say 7.45, that seems more realistic, but look at how the waveform is dropping in voltage and then coming back up in voltage. I think my 9 volt battery is nearly flat, so I'm just going to find out what's in the battery. .9 volt, okay. It's getting on the borderline of not being enough power for the op amp, but it's still functioning to a point. Okay, now to build the output stage section. Okay, the output stage is built now apart from the Zobel network. This is a large 470 microfarad 63 volt capacitor because the 100 microfarad that I had, one of the leads broke off. So anyway, this amplifier is currently unloaded, so I'll turn the pot up, and as we can see we are getting an output. So now if I put an 8 ohm dummy load across it, what sort of voltage are we going to get out of it? Well, let's find out. Okay, the 8 ohm dummy load is connected to the output. Okay, so let's crank the control up. Oh, we are getting an output, but it's starting to clip around the 1 volt region. That's as far as it goes, about 1.5 volt. Alright, so that's going to be 0.75 volt multiplied by itself equals that divided by 8. 70 milliwatts. Probably with a fresh battery it'd be better. So I do notice there is some ringing there, so I might want to actually put the Zobel network in. Well, I couldn't find a 10 ohm resistor because I haven't bought any recently. I've only had a 68 ohm, so that would have to do. It's not really having that much of an effect, but certainly speaks a lot louder than the other one did. So let me hook it up to a music source and we'll have a listen. It's a bit distorted. Alright, I changed the input capacitor to a 100 nanofarad so it's not passing so much bass. That really should be a 10k potentiometer. Now we're into distortion. It's not the best. I wish I had another 100 microfarad capacitor instead of that 470. Actually, I wish I had a lot of things like a pony. Yeah, well, it is working. It'd probably work better on a TLO 7.2 rather than the NE5532. The NE5532 is just barely operating. Barely operating. Let me try this tip again. This transistor's aren't even getting hot. Okay, well that deserves a beer. look at the head on that. That's what she said. Right, let's close this one out. Okay, there's a final look at our schematic. I would put a 10k pot here, probably make that 100 nanofarad just to roll off the bass a bit. Because with a tiny little speaker at the other end, it's not that great. If you use a bigger speaker, it's probably alright. Now, that should be 100 microfarad. I'm using 470 because, well, the legs broke on my 100 microfarad capacitor. It does work. It doesn't have as much volume as I remember when I built it the first time. But then again, I am using an NE5532. The concept does work. TL072 would probably work better. Just saying. So keep it to TL072. Be sure to connect these the correct way around in the correct place, or things will start to heat up. And those transistors will heat up quite considerably quickly. Ask me how I know, because I already did it earlier today. Anyhow, now for the front end, I would put through another capacitor. I would go through a loading resistor here on the input, just to keep the impedance down. Then I go through a 10k potentiometer. Into the front end of that amplifier. And it wouldn't hurt to have a little ceramic capacitor here, say 470 picofarad, just to stop it picking up radio frequencies. This can also be 100 nanofarad. That's just for context there of how you'd wire the volume section to it. Want to see this little circuit built up on VariableBoard? Leave a like and a comment down below and I'll do it. So what would you use this little amplifier for? Well, originally I used it to amplify an MK484 or a ZN414 radio IC, which worked reasonably well. You could also use it as the basis of a signal tracer, if you so wish. Anyhow, I'm going to leave this one here. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can become a patron for as little as $1 a month. The links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, have a great day. So I'll leave you with a clearer copy of the schematic on the screen, and a little bit of Otis McDonald.